everyone, it's me Jawaria Jabeen and welcome to my YouTube channel. Today I am going to clear the concept of action potential. The learning objectives are: number 1, we will discuss about resting state potential and then phases of action potential, which include depolarization, repolarization and hyperpolarization. So let's start the topic. All the activities of the human body are well coordinated, and this coordination is developed by nervous coordination. In the nervous coordination, the nerve impulses are conducted along the nerves in all over the human body. All the nerve impulses are conducted in the nerves by a process of action potential. In action potential, the polarity of the ions, or you can say the potential across the cell membrane of nerves, is changed and the nerve impulse is conducted. In resting state, inside charge is negative and outside is positive, and in action potential it is reversed. Let's discuss the process of action potential in detail. By definition, action potential is temporary reversal in the potential difference across a plasma membrane that occurs when a cell has been activated by a threshold stimulus to conduct nerve impulse. An action potential is initiated when the stimulus is strong enough to depolarize the plasma membrane from the resting state potential, which is about minus 70 millivolt. Threshold stimulus is the minimum stimulus needed to produce the action potential, and it's about minus 55 millivolt. Once nerve is activated, the action potential is proceeded in 3 distinct phases. Number 1 is depolarizing phase, number 2 is repolarizing phase, and number 3 is after hyperpolarizing phase. At resting state potential, intercellular is negative charge and extracellular is positive charge. Voltage gated sodium channels and potassium channels are closed. When the nerve is activated by a threshold stimulus of about minus 55 millivolt, the depolarization occurs. Voltage gated sodium channels are opened. Sodium ions start moving inside the cell by passive transport along the concentration gradient, and it causes more depolarization, and the intracellular charge is now positive and extracellular end is negative. The potential difference across the plasma membrane increases, and the maximum resting state potential ranges from plus 30 millivolt to plus 35 millivolt. When plus 30 millivolt is achieved, the sodium channels are closed. They close after 1 millisecond when they open. Their closure stops the inward movement of sodium ions, and now voltage gated potassium channels are opened, leading to the repolarizing phase. In repolarization, the outflow of potassium ions occur and plasma membrane is repolarized by intracellular negative charge and extracellular positive charge. The potential difference across the membrane decreases due to repolarization to about minus 70 millivolt. Then hyperpolarizing phase occurs. During hyperpolarization, the outflow of potassium ions is prolonged, which causes the potential difference across the membrane to decrease to about minus 90 millivolt. The outflow of potassium ions is prolonged due to the slow and late closure of voltage gated potassium channels. After the potassium channels are closed, the sodium potassium pumps and potassium leak channels are activated to restore the concentration of sodium and potassium ions. Hydrolysis of ATP occurs, and sodium potassium pumps actively move 3 sodium ions outside the cell membrane and 2 potassium ions inside the cell membrane. This active transport against the concentration gradient decreases the potential difference to minus 70 millivolt, which is resting state potential. Let's summarize the topic of action potential. The resting state potential is minus 70 millivolt. The threshold stimulus of about minus 55 millivolt is needed to depolarize the resting state potential. In depolarization, the voltage gated sodium channels are open, which passively moves sodium ions inside the cell, and the potential difference is increased to plus 35 millivolt. The maximum depolarizing potential closes the sodium channels and opens the potassium channels. The opening of potassium channel passively moves potassium ions inside the cell membrane, and repolarization occurs to minus 70 millivolt. Due to slow closure of potassium channels, the potential difference decreases to minus 90 millivolt, which is called hyperpolarization. After hyperpolarization, sodium potassium pumps actively move three sodium ions outside the cell membrane and two potassium ions inside the cell membrane, which increases the potential difference to minus 70 millivolt, which is resting state potential. Thank you so much, and if this video is helpful for you, so don't forget to like, share and subscribe. See you in the next video. Bye bye.